Hello, this video is on section 10.2, which is titled Simplifying Radicals, and learning target for this is to simplify radicals involving products and quotients. So before we get started, you should be somewhat familiar with the radical. That's this black symbol right here. That means you are finding a number that is multiplying it by itself that's equal to the number underneath. So if you want to find the square root of 24, you need to find one number times itself that's going to equal to 24. And unfortunately, there is not a whole number that can multiply by itself to get 24, but there's a way we can simplify this radical so that it's not written as a decimal. And the way you can do that is to separate the number up into two different factors by separating the radicals as well. So for example, when you're looking at factors of 24, one set of factors is 1 and 24, then there's 2 and 12, 3 and 8, 4 and 6. And when you're looking to find the factors of the number to simplify it, you need to find the ones that are the perfect squares in order for you to be able to simplify it. So the perfect squares of these factors, that one is 4. So when you separate the square root of 24 into the two factors, it becomes the square root of 4 times the square root of 6. Because then what you're able to do is to actually take the square root of 4 and rewrite that as a whole number in itself, which is 2. So the simplification of the square root of 24 is equal to 2 times the square root of 6. And the exact same thing can be applied to division. If you have a square root of a fraction, you can separate them into the square root of the top divided by the square root of the bottom. So the square root of the fraction 4 over 9, well, entirely it's not going to get you a whole number all the time, but in this case you're able to separate it into the square root of 4 divided by the square root of 9. You are able to take the square root of both of these terms, which gives you 2/3. So just looking to find the factors, simplifying them individually in pieces, and then combining them back together. Now the next thing I want to go over is how to rationalize a denominator. And whenever you write a rational expression and you have a radical in your denominator, it's not considered a rational number. You have to rewrite the number without the radical symbol appearing in the denominator. So the way you can eliminate that is by taking whatever your denominator is in the radical and multiplying it by the top and the bottom. Because whenever you multiply these across as a fraction and you multiply the denominators, the square root of 7 times the square root of 7 gives you the square root of 49, which that is then going to be equal to 7. Well, if we do the top first, square root of 3 times the square root of 7 is square root of 21. And the top cannot be simplified because there are no perfect square factors or any way we can simplify this. But the bottom, you can take the square root of it. So now this is a rational expression. It doesn't have any radicals in the denominator. It's just a whole number. But we'll be working on those in class on some more difficult numbers and maybe some different expressions on how we can get that denominator to be rational. All right? Thank you.